I'll try to find some additional normal questions for you to do that I'll post into BBLearn. A company installs 5,000 light bulbs. Each bulb has an average life of 500 hours, so we all now know, I hope, that as soon as they say the word average, that means expected value. So the expected value is 500, with a standard deviation of 100 hours. The life of each bulb is approximated, of each bulb, so that's what's interesting, by a normal curve. Find the number of bulbs that can be expected to last between 290 and 540 hours. So we need to find the probability that a single bulb lasts between 290 and 540 hours. Once again, we need to standardize. To standardize, you subtract the mean, which is 500, and divide by the standard deviation on all three sides here. Okay, now I need to do some calculating. 290 minus 500. Over 100. So this is the probability of negative x. Well, actually now this is z, remember? Once we subtract the mean and divide by the standard deviation, we now call this z, because this has become a random variable whose expected value is 0 and whose standard deviation is 1. And on the right, we get 0.4. So now, I don't know if you remember this from the easier problems, to find the probability of lying between two values, you do the probability of being less than the bigger value minus the probability of being less than the smaller value. So now I have to find 0.4 on the edge of the table. 0.40 is the probability of being less than 0.4 is 0.6554, provided that I can see, because it's very tiny. 0.6554 minus the probability of being less than negative 2.1. So negative 2.1, that's negative 2.10, which is right here, which is 0.0179. So I'm subtracting I already forgot the number, 2.1, 0.0179. Which equals 0.6375. Now, the question goes on. I already recorded this once, but something happened to it. So let's try it again. A company installs 5,000 light bulbs. Each light bulb has an average, so now before I even say anything else, the word average should start to have a meaning to you. It always means the expected value. So the expected value for these bulbs is 500 hours, with a standard deviation of 100 hours. The life of each bulb is approximately a normal curve. Find the number of bulbs that can be expected to last between 290 and 540 hours. Okay, so we can't look at all these bulbs together. We have to first find the probability that an individual bulb, which is what X is representing, lasts between 290 and 540 hours. And then we'll deal with the 5,000 at the end. So once again, we know that these are normally distributed with an expected value of 500 and a standard deviation of 100. So now we need to standardize again, which we do by subtracting the mean and dividing by the standard deviation from each part of this inequality in the middle. So again, this is a complex inequality. It's got three sides. We will simply subtract 500 from all three sides and divide the standard deviation on all three sides. So we will do the probability of 290 minus 500 divided by 100 is less than x minus 500. And again, it doesn't matter if you use the equal bar or not, because it will not change these probabilities. Is less than 540 minus 500 over 100. And I can do the calculations again. So 290 minus 500 is negative 210. Divided by 100 is negative 2.1. Oh, oops, I don't know what I just did there. Now, this thing again. Once you subtract the mean and divide by the standard deviation, the purpose of doing all this is to transform this random variable x into this whole expression, which is now a standard normal random variable. So once you do the subtracting and dividing, you can call the thing in the middle z, because z is the standard normal random variable. And then on the right-hand side, you end up with 40 over 100, which is 0.4. Oops, I keep touching something at the bottom. Now, I hope you remember from the beginning that when you are finding the probability of being between two values, you do the probability being less than the upper bound minus the probability being less than the lower bound. So now I have to find 0.4 on the outside of the table, because now I'm being given my z value. This is the z value, and we're looking for the probability, and the probability is what is in the table. So 0.4, positive 0.4, here that is 0.4, 0.40 specifically, so it's 0.6554. And then we have to find the probability being less than negative 2.1. So negative 2.1, here's negative 2.1, 0, so it's 0.0179. 0.0179. I couldn't remember the number, so I picked any color. So 0.6554 minus 0.0179 is 0.6375. So this is the probability that a light bulb lasts between 290 and 540 hours. A single bulb. The question, if we go back and read it at the beginning, a company installs 5,000 light bulbs. And then the question is not find the probability, it says find the number of bulbs that can be expected to last between this period of time. This is somewhat intuitive, but it may not be something that's going to jump right out at you. This is the probability now of success, right? This is the probability that a bulb does what you want it to do. So the expected number of bulbs that will last between 290 and 540 hours will be the number of bulbs, which is 5,000, times the probability a bulb lasts that long. And I'm calculating that. Oops, except I did it wrong. 0.6375. Typo. You get 3187.5. And if you check the answers, this rounds up to about